Hey y'all, Data Guy here, and today I have yet another viewer request video where I'm going to show you how you can migrate your data from a Redshift database into a Snowflake database. Now, the fact that I'm migrating it into a Snowflake database doesn't really matter. This flow will work for pretty much any Airflow data or any database that is supported by Airflow, has an official operator, or even doesn't. As long as you can interact with it through Python, through SQL, through an external connection, you can probably use this flow to migrate your Redshift data into that database. And I'm not only just going to show you, copy paste. I'm going to show you how we're going to do schema mappings here, how we're going to incorporate transformations, and also just give you things like data type conversions as well, because typically when you're moving data from one source to another, it can get tricky with data types because not every database uses the same type of data types, Snowflake being one of them. So I'm going to show you how we can do that conversion as well, so you can have an easy, smooth migration process that you can use for all of your DAGs. So to get started, just going to create a fresh Airflow environment. So cd into desktop, data guy, and then directory, Redshift migration. And now we're in here. Let's go into cd, Redshift migration, and then astro dev init. And this will just initialize an empty Airflow folder structure. So go in here, go down to this Redshift migration folder, open it up, and boom. Now we just have our typical kind of Airflow setup down here. And the first thing we're going to want to do is within our requirements file, add our Snowflake and Redshift providers. So here, get the right names. So here we're going to import Apache Airflow providers Amazon and Apache Airflow providers Snowflake. Everything else we're using comes baked into the regular Airflow install, so you don't need to worry about adding anything else. And then we'll just go to create our DAG. So Redshift migration DAG .py. Awesome. So now we're ready to get started. And so we're just going to import a few different packages, not a super robust package list because we're not really doing anything crazy. We're really just interacting with Redshift and Snowflake. So here we're going to import DAG, the DAG and task decorator, so we can use the Taskflow API. Then we're also going to import the Redshift SQL hook and the Snowflake hook. Because we're kind of doing some transformations as we're inserting the data, so I'm using hooks rather than the actual providers. I just found some additional flexibility in there, but if you want to use the providers instead, official providers instead, you also have that option. And then we just have this days until utility for scheduling purposes. Then, once we have all of our requirements set down, so let's bring in our basic default arguments. Nothing really too important here, but just always good to have them. Some retries, some conditions for failures, and then we can define the start of our DAG. So here, just import our default args, daily schedule, calling it super basic Redshift to Snowflake because I'm not creative today. And then what we're going to do is define our first task. So here, what we're going to do is extract data from Redshift. So use the Taskflow API, write a Python task. We're going to notice these are pretty much all going to be Python tasks to give me that additional customizability here. And then within the task, what we're actually going to do is just have a simple Redshift hook. I actually forgot to do something. So before we even get started writing this task, we need to go back and also set some arrays for our different mappings. So the reason why we're doing this rather than kind of mapping within the context of the task is this allows us to easily have a single source of truth. This is also something you could have saved as environment variable, have saved somewhere else, where you have all the mappings between your Redshift table and your Snowflake table. So if any of these columns change, if you need to add more mappings, it's really easy to do that. So you'll see later within the actual different tasks that I have, they're going to iterate through these schemas and map, hey, this column in Redshift to this column in Snowflake. And rather than having that hard-coded in the DAG, it's a much better strategy to have an array that is then iterated through for each of these mappings. Much more robust solution, and definitely one that you should take advantage of. And then additionally, kind of for this exact same purposes, we're also going to set our data type conversions up here. So here we're going to say, hey, for this column, Redshift column 1, this needs to be an integer within Snowflake, so we're going to convert that to an integer. This needs to be a float. This needs to be a string. This needs to be a date time. So you again have that single record that you can iterate through and say, hey, transform this data into this, transform this data into this, without having to hard code it and having just this array to go back and reference. So now we can actually get started on our DAG, so extracting data from Redshift. So what this task is going to do is use that Redshift hook we installed to initialize a connection to Redshift, then select all from your Redshift table. So you put your table name in here, and then data Redshift hook using the get data's pandas data frame function on that SQL statement. So what this get pandas data frame function does is take the results of a SQL statement, which in this case is this, and then turn it into a pandas data frame. Then we're just going to return that data to JSON, so orient split, so split the data. And what this split basically is doing is just saying orient this where our keys are our columns. So the names of each of these columns are set as the columns within Snowflake, or within the pandas data frame. And then fix that there. So this task is done. We have our data extracted from Redshift. So next, what we're going to do is actually transform that data. So here we have our next task, which is just going to be simple transform data. And then here we're going to bring in that data JSON. And then we're going to go through, based on the schema mapping, and rename all of our columns within a data frame. So here we have pandas data frame re-JSON, and then we have orient split. Then we're renaming the columns based on those schema mappings. So here we're passing in the array schema mapping that we set up here that will then say, hey, based on the column that's already called, so Redshift column 1, call this now Snowflake column 1, and do it in place. So you're not actually creating new columns, you're just relabeling existing columns. So that's a key flag to have there. So once we've relabeled the columns, we're then also going to convert the different data types. So you can see here for data column, convert that as data type from this data column conversion. So data type conversions reads out those individual items for each of those columns, change them to the type that is assigned to that particular column based on this array up here. So again, easy way to just iterate through there. And then additional transformations. So this is just some examples of additional transformations you could do if you wanted to customize the columns or collate them. So in this example, calculating a new column based on existing columns, summing up these two columns. And then you could also have things like conditional transformations. So hey, if this data is a string, or if it's above the upper realm of this column, then I want to remove it from there, or I want to apply a function to it. And you also have things like data formatting, where you can do additional transformations to make sure it's in the datetime format that your database likes best. So you have that functionality there too. So just wanted to give you a couple different examples of ways you can transform your data here as part of the migration process, because it's likely going to be something you're going to need to do. And then again, just saving it to JSON to be able to pass it to our next task. And so our next task is just going to be loading that data into Snowflake. So here, to find the task, load data into Snowflake, have that data JSON passed again. And then what we have is quite a few different operations, so we'll go through this slow. So first, again, reading in our data. So pandas reading that JSON that was passed in, then initializing a Snowflake hook. So Snowflake hook to initialize and connect into our session. Then we're going to create a temporary CSV file for Snowflake stage. Makes it easier to upload from basically a CSV file stage into Snowflake rather than directly from that JSON file or from a pandas data frame. And then what we're going to do is put your CSV to Snowflake stage. So essentially so wherever your CSV file is, we're going to save this temporarily to this temp path. So you can use this existing temp path, or you can change it, it really doesn't matter. And then what we're going to do is open that temporary CSV and then use the Snowflake hook to put that file, which is again just leveraging that temp CSV path, into your Snowflake stage, and then auto compress equals true. So you can't upload data directly into a Snowflake table. You have to upload it into a stage, and then you can copy it into a Snowflake table. So once it's in that stage, then we're going to run the Snowflake hook again to copy into our Snowflake table from Snowflake stage, and the file format is going to be CSV. If you need to add your own conditional file format, if you're working with non-standard data, you might need to create a custom file format, but I'm just going to use a generic one here. Skip header, and then field might be enclosed by slash. So just giving some basic characteristics of what the CSV file looks like so it gets imported properly. And then cleaning up the temporary file, just importing OS and removing that temp CSV. And then that's it. So the only thing left to do is just actually define these different steps within the data. So data, extract data from Redshift, transform data equals transform data data, load data into Snowflake, again using that transform data, so just passing that data in between those functions using the Task API. And then finally, defining the DAG. And that's really all you need to write to have an Redshift migration DAG. So let's pop over into the Airflow UI. I'll quickly just show you, hey, where you need to set up your connections, show you what the DAG looks like, and then you're on your way. And so here you can see, if we go, and I'll go to the DAGs view first, but Redshift to Snowflake, very simple DAG within the Airflow UI, just extracting data, transforming it, and then loading it into Snowflake. In terms of connections, what you'll need to have, if you're not setting them as environment variables like I do, is first we're going to need to have a Snowflake connection, and so Snowflake default, and then you're typically going to need your schema, login, password, and then account name is going to be something like this. So it's going to be -- and you don't need your region name anymore. Put your role in, and then database, and that should be it. You can also use the private key path, but I don't. Save that, and then also save your Redshift default. So Redshift default, Redshift, not Redis. And so for here, I end up just using a username and port, so user, pass, and then that's pretty much it. But there's a few different ways of connecting to Amazon. I just use temporary credentials, but whatever you use, you can probably use here to connect to Redshift. So that's really all you need to do. Hope you enjoyed this video. Hope you find it useful. So happy migrating. Data Guy out.